Hello. Before I start the lecture, I wanted to um, talk about the midterm assignment. It's due in 2 weeks, um, and there's two versions of it. Uh, to remind you, there's the exam version and the paper version. It's completely up to you which one you do. The idea is that the exam version is easier than the paper version. And most people usually end up doing that because it's easier. Um, the amount of writing is the same. It's 4 to 6 pages. Uh, if you do the exam version, you answer 2 out of the 8 questions that I ask here, 2 to 3 pages each. Um, and it's easier because you don't have to think of your own question. I've already written the question. So you just have to, um, you can assume for these purposes it's a good question and try to answer it. Whereas when you write a paper, you have to come up with your own question, and also part of the paper is, trying to explain why the question is a good question. So that's an additional um, and often difficult part of writing a paper. Um, Let me see if there's anything I want to emphasize in the instructions here. Um, It's due on Canvas. Either one is due on Canvas by 11:55 p.m. Um, and the questions on the exam version are keyed to different reading assignments. That doesn't necessarily mean that you can or must only use material from that reading assignment to answer it, but they each one of them deals with um, focuses on material that's raised in one reading assignment, or I guess there's only one question for Goodman, so that covers both of the assignments from Goodman. Um, and it goes through the reading from Quine for next week, which is the end of the first part of the course. So, um, and then the final assignment will cover the last part of the course. Anything else here? Well, yeah, so just, there's a paragraph here saying your focus should be on answering the questions accurately, not on making an original point or argument. If you do want to make an original point or argument, you should choose the paper version rather than the exam version. For the exam version, and don't write like an introduction and a conclusion or a summary of, everything else that's relevant in the text. Just try to say what you need to answer the question. Okay. And then is there anything I want to say about the paper version? I'm not going to spend a lot of time on this because, like I said, it's usually not that many people who do it. But, um, first of all, these are suggested topics. If you want to write a paper about a different topic, as long as it's clear that the paper is relevant to the course, that would be fine. These topics are like kind of open-ended and have a lot of different sub-questions to them, right? That's because you're supposed to kind of like they're different suggestions for how you might approach the main question of the topic, basically. So maybe think about this question or think about that question. It's not like a list of things that you should do to write the paper. Um, and And if you do write a paper, I recommend, I mean, it's not required exactly, but I recommend that you write a paper trying to interpret the text we've read, right? Like trying to make an argument about what the author means, why they're saying what they're saying, that type of thing, as opposed to trying to decide if the author is right or wrong about the underlying topic. And if it's unclear what I mean by that and you want to write the paper, feel free to ask me either now or by email or office hours or whatever. Okay, are there any questions about this assignment? Okay, I guess not. I'll switch to this. Oops, this is not the right notes. This is the right notes. Okay, so I'm actually going to leave this picture up here because I think you're going to need it again soon, but I'm going to erase this and write induction. Right, because so in this part of the book, Goodman shifts from talking about projection and dispositional predicates to talking about induction. Now, how much of a shift is that? Well, like to begin with, on page 58, so this is at the end of chapter 2 when he's segueing into chapter 3. He says, I guess actually I should start on page 57. Now the problem of making the projection from manifest to non-manifest cases is obviously not very different from the problem of going from known to unknown or from past to future cases. Right, so what he says when he introduces the transition to talking about induction, right, so I mean, I guess maybe I should say what induction is. Maybe I shouldn't assume everyone knows what that means. Induction is the supposed process where you want to, and I say supposed because Popper is going to say there is no such process, basically. But it's the supposed process where you have a general law, like all copper conducts electricity, and you try to build up support for that law by examining, let's say, different pieces of copper and seeing if they conduct electricity. And every time you find one that does conduct electricity, it helps to confirm the general law that all copper conducts electricity. That's the way induction is supposed to work. So, I mean, you can think of it this way. The general law has a lot of different consequences. Some of the consequences are, right, that is, it implies for each individual piece of copper that it conducts electricity. So some of the consequences are the ones you've already observed. I observed that this piece of copper conducts electricity, and this one, and this one. And others are ones that you haven't observed, but you may observe in the future. Right? So another way to look at induction is I'm trying to make predictions for future tests based on the ones I've already conducted. Right? That is, I'm trying to use the consequences I've already observed to confirm the general principle, and then from that deduce future consequences that I haven't observed yet. Right, so to begin with, when Goodman switches to talking about induction, he says that induction is evidently a similar problem to the problem he's been discussing so far about projection. But when he gets to the end of chapter 3, He says, "Today I have been speaking solely of the problem of induction, but what has been said applies equally to the more general problem of projection. As pointed out earlier, the problem of prediction from past to future cases is but a narrower version of the problem of projecting from any set of cases to others." Right? So by the end of the chapter, we've realized that the problem or problems about induction are not just similar to the problems about projection, but in fact, they're a special case of the general problem of projection. Um, okay, so how do we get to that? So the overall question about induction is, or appears to be, something like this. Why, based on the fact that this piece of copper has conducted electricity and this one and this one and this one, am I justified in predicting that in future, and I guess maybe I should say that this one has conducted electricity at a certain time, right? Because of course, like even for that very piece of copper, it's only a prediction that it will continue to conduct electricity in the future. So, how on the basis of these observations, this piece of copper conducted electricity on at such and such a time, this piece of copper conducted electricity at such and such a time, how am I justified in making the prediction that in the future, all pieces of copper that are tested will be found to conduct electricity? Um, So Goodman says that if you understand that question the wrong way, it's not a good question at all. So what would be the wrong way of understanding it? Something like, how do we know that it's true that in the future all pieces of copper will conduct electricity? Or if you want to say, well, we don't know for sure, how do we know that it's probable that in the future all pieces of copper will conduct electricity? And Goodman says, we don't know. So that's a bad question, right? It might turn out that they don't. Right, so as he puts, if we switch back to the document camera again, he puts it on page 62. Now, obviously, the genuine problem cannot be one of attaining unattainable knowledge or of accounting for knowledge that we do not in fact have. Since, in fact, we don't know what's going to happen in the future until the future comes, the problem, if it's a good problem, can't be that problem of how do we know that the future will be like the past in some respect. And he says this by way of, I'll come back to more about Hume if there's time towards the end, but he says this by way of claiming that there isn't some big piece missing from Hume's solution to the problem of induction, that it isn't a solution, but a solution to the problem of induction. Right, as opposed to many people who have thought and many people who continue to think that what Hume pointed out is that this problem has no solution or something like that. He's saying that if the problem he's saying what these people say against Hume is, sure enough, you explain how it is that we come to expect that the future will be like the past, but you don't tell us how we're justified in expecting that. That is how we know the future will be like the past. So that's not a solution. And Goodman says, well, if that were the problem, it shouldn't have a solution because we don't know. All right, so I mean, that's actually a very radical move, in fact, both in Hume interpretation and in epistemology, but he just passes that over very quickly at the beginning. And so, if that's not the problem, what is the problem? And so basically, the problem is, and this is quite similar to what he said about dispositional predicates. I mean, in effect, one way of understanding the move he's made here is to say that statements about the future or predicates that refer to the future are unacceptable without further explanation. Just as predicates that refer to the possible but not actual are unacceptable without further explanation for Goodman. And when you put it that way, you can already start to see how one might look like a special case of the other, right? Things that have not happened yet, but might happen, are a special case of things that are possible but not actual. And so the approach to them, therefore, is going to be the same as the approach we saw before with dispositional predicates and with the possible in general. What we need to do is to translate these statements that apparently make predictions into statements that don't make predictions, statements that are only about the present and I guess also the past. He doesn't go into that so much, but I mean, at least in this context, he doesn't ask how do we know about the past. That, at least for the time being, seems to be acceptable and not unacceptable. To say something like, yesterday we observed that this piece of copper conducted electricity. So it's like this. I mean, if I could go back to, is it more confusing for me to... Yeah, I'm going to go back to the example of rubber that we were talking about before. So I'll erase some of these lines, although I'm going to draw them again afterwards. So what we have here is something like this. The condition that before I called C is now like has been examined, has been tested. And among the things that have been tested are certain pieces of rubber. So examined or tested here like includes whatever kind of tests we have to do. Well, I guess, so let me say, okay, so here, maybe I should switch to copper. No, I'm going to keep talking about rubber. So, right, the general law we're trying to support is going to be all rubber bends under suitable pressure. Right? Or in the case of copper, it would be something like all copper conducts electricity when it's connected to a, a circuit with a voltage difference. Right? I mean, of course, copper doesn't conduct electricity when you're not running electricity through it, just like rubber doesn't bend when you're not putting it under pressure. So the full statement of the law is something like all rubber bends when under suitable pressure. And so the condition here actually turns out to be pretty much the same condition we were talking about before, right? That is, the condition that the rubber has been examined is the condition that it's been put under suitable pressure and observed to see whether it bends or not. It's not exactly the same condition we were talking about before, right? Like the old condition was just that it's been under suitable pressure, whether anyone observed it or not. But here the condition is, it's been observed under suitable pressure. And of all the things that have been observed under suitable pressure, some of them bent and some of them didn't. So in here are the ones that bent when they were examined under suitable pressure. And in here are the ones that didn't bend when they were examined under suitable pressure. Like steel beams that were put under suitable pressure and were observed not to bend. So, we want to project this line between things that have bent when examined under suitable pressure and things that have not bent when examined under suitable pressure out to the realms of things that have not yet been examined. Right? So that's the future to the past part of it. Right? The past, because this is everything that has been already examined, this circle is about the past. The predicates that are applied to things, as long as we only apply them to things in this circle, only talk about past observations, not about future ones. Out here, we have, well, at least put it this way, everything that will be observed, examined in the future is out here outside the circle. Also, everything that will never be examined, even in the future, is outside the circle. Of course, it doesn't make sense to make predictions about those things, right? So they're not very interesting. But as a matter of fact, everything that has not yet been observed, examined, whether it will be or not, is outside the circle. So in drawing this line here, trying to project the difference between has been examined and found to bend, and has been examined and found not to bend outside the circle, where the interesting part is that we're dividing all the things that will be examined in the future into those that will be found to bend and those that won't. So, I mean, this whole part, again, is like this, basically the whole thing you can call flexible, or at least like examined and found flexible. But where now examined is, as Goodman would say, tenseless, right? That is examined at any time ever in the history of the universe and found flexible. That's the predicate that we want here. But that predicate is unacceptable because it includes all these future things. And so this is the acceptable predicate, right? This is what before I called QM, where M was for manifest. And, examined and found flexible is a manifest predicate. Um, so, um, right? So this QM is the acceptable predicate because it only talks about actual things that we have observed in the past or in the present. But we want to extend it to this other predicate, which we can call, you know, will ever be examined and found, has ever or will ever be examined and found flexible. Right? So, and the question is how to do that and get rid of that unacceptable part that says will ever. Because again, basically, in saying we just don't know what will happen in the future, he's saying we don't really have a right to talk about that. It's unacceptable. It goes against my philosophical conscience. Are there questions about this so far? Okay, so um, so this just is a problem of projection, projecting a predicate, projecting a manifest predicate into basically a dispositional predicate, right? That's why I said, I mean, you could call this whole thing flexible, or more accurately, flexible upon examination, or like examination hyphen flexible, as Goodman might say. Right? We're trying to sort everything, whether we've examined it yet or not, into two groups. We're going to, call one examination flexible and the other examination inflexible or in examination flexible. Right? So, so it's just exactly the problem he was talking about in chapter 2, right? And that's why by the end of chapter 3, instead of saying it's like that problem, he just says it's a special case of it. Right? It's a special case. Which special case is it? It's the special case basically where, where we include this piece about examined in the um, in the condition. So we're trying to go from the cases we know to the unknown cases. Whereas in the general problem about dispositional predicates, we weren't yet worried about whether we know, right? So like all rubber everywhere that is under suitable pressure at a certain time flexes, whether we know about it or not. And then the question is, like, how are we justified in saying the rubber that isn't under a suitable pressure at that time, again, whether we know it or not, flexes? Here we've added this condition about examined, and therefore it's not really about past versus future. That's a little bit loose, as Goodman says when he talks about this on page 90. Now, is that really the right place to read? Because he talks about this earlier, but I didn't write down where. I guess I'll just read this. All right. This is not the right page. Page. When all the undetermined cases of a hypothesis are future cases, its projection is a prediction. Very often, however, the undetermined cases may be past cases. And here we have a projection that is not a prediction. Of course, the determination of undetermined cases is always later than the projection in question, but such a case may nevertheless be a statement about what has happened prior to that projection. Right? So, I mean, actually, I don't know how much emphasis to put on this. he thinks it's important for avoiding certain problems that come up in pragmatism or with pragmatism. But the thing he's pointing out is that like if you're talking about an event that happens at a particular time, then so like the law, all copper conducts electricity, applies to makes predictions about copper that will be examined in the future, will be tested in the future, but it also makes, so to speak, predictions or retrodictions about copper that was never tested in the past. So, but there might be some way of testing in the future whether that copper actually conducted electricity in the past. So if we have something like that, we can also use our general law to predict the result of those tests. So overall, the difference here is not really between future and past, or it's between examined in the past and examined in the future, or tested, or the term he's using is determined, right? Determined in the past versus determined in the future. Determined meaning like we determined whether it's true or false. When did we determine whether it's true or false that this piece of copper conducted electricity? All right, if you find that confusing, like I said, I'm not sure how important it is, so maybe you should ignore it. So the main point, however, is that the problem of induction, the solution of it, therefore, is going to have the same form as the solution to the general problem of dispositional predicates. Namely, we find a certain auxiliary predicate A that always goes along with the manifest predicate QM within the circle of the condition. Right? So that is remember, when I talked about this last time, I said, like that auxiliary predicate, you could imagine it just being a long list of disjuncts, like is rubber, or is a certain kind of plastic, or is grass, or is cardboard, or, right? So, that like basically just it could be just a list of all the things that all the types of material that have been found to bend under suitable pressure. And again, like within the circle of the condition under suitable pressure, that list of predicates has exactly the same extension as the manifest predicate flexes, right? That is the manifest predicate that says bends under suitable pressure. But unlike the manifest predicate flexes, the auxiliary predicate A also applies to other things outside the circle, right? So it's extensionally equivalent to QM inside the circle, but it also applies to other things outside the circle, and that's how we're going to use it to project, right? So in the general case of dispositional predicates, the projection is, well, we call something flexible if it has this predicate A. So again, it could be just a list of all the kinds of things that we've found to flex. Then, though, you have to be careful about what counts as a kind of thing and what doesn't. Right? Like, all pieces of rubber and all steel beams all belong to a single kind of things. What kind? The kind of things that are either rubber or steel. I have a cat trying to climb me here, but you can't see it, unfortunately. It's not even close to time to feed you, Lily. What are you doing? All right, I don't know. Anyway, If you don't, be careful. I might pick you up and show you to the class. Okay, so, right, so you have to be careful. The kinds have to be the right kinds. They have to be kinds that are projectable. So, and if we, I mean, we could try to say something more reasonable, manageable for this auxiliary predicate. Maybe we discover certain physical properties, the general physical properties that all those things have in common, and then we're going to equate those with flexible. But it still has the same problem, like everything has some physical properties in common. Everything physical, I guess, has something physical properties in common with any other physical thing, right? Like, you know, suppose rubber has a certain molecular structure, and steel has, crystal structure. I don't know. Anyway, steel has another microscopic structure, but there's a physical property that is having either this microscopic structure or that microscopic structure, and steel and rubber share that physical property. So again, you need a way of saying why that's not a good physical property. That is, you would need that. Why? What would you need that for? You would need that if you wanted to solve the general problem of how to go from QM to A, which would be the general problem of how to project dispositional qualities. So in the case of induction, since it's exactly the same problem, the strategy is going to be exactly the same, or it's a special case of the exact same problem. The strategy is going to be a special case of exactly the same kind, of exactly the same procedure, right? So now the manifest predicate is, that we're calling QM, is like has been examined and found to bend under suitable pressure. Right? That's what in this case we could call flexes. The things that flex are the things that have been examined under suitable pressure and found to bend. And right, we want to expand to this predicate, to project into this predicate QD, which covers all of this territory. And the predicate QD is, again, like has ever been or will ever be examined and found to bend under suitable pressure. But we don't want to say that because, again, it contains this reference to the future contingents, which is unacceptable. And so how are we going to do it? We want to find a manifest predicate that matches QM inside the circle of the things that have actually been examined. And then we're going to translate that apparently predictive statement into a statement that just says, right, so right, instead of saying all rubber that has been or will ever be examined under suitable pressure bends, instead we say all rubber is A. Now, I mean, you might think, how does that help the problem? How do we know that the rubber we haven't examined is A? But again, like, so one possibility, and in most of this chapter, I think Goodman is implicitly going with this as the possibility for what A is going to be. One possibility for A is that A says is rubber, or is plastic of certain kinds, or is cardboard, or is grass, etc. So if part of A is rubber, then of course we know that all rubber is A. A is not going to be the same as is rubber, right? Because there are other things that we also predict will bend based on having examined samples of in the past, not just rubber. But one of the things that's going to be part of A is going to be, again, is going to be a disjunction. To say that something has this manifest property A is going to be to say it either is rubber or blah, 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 blah. But, as soon as you say, you only have to say the first part, either is rubber or blah, 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 and you already know that all rubber is A. So, the apparently clairvoyant statement that all rubber that will be examined in the future under suitable pressure will be found to bend translates into the very non-clairvoyant statement that all rubber is rubber. There's no question about how we know that. Well, there might be some question, and Goodman says something about analytic synthetic distinction, which will come back to bite us in Quine. But any case, there isn't the same kind of problem about how we know that all rubber is rubber. So again, and so you might say, well, wait, hold on a second. So what problem did this solve then at all? The problem it solved is to find a manifest acceptable predicate that has the same extension in our use as the predicate has always been and will always be found to bend under suitable pressure. And that just means that all and only the things we're willing to say A about are the things we make that prediction about. Right? Again, only the logical meaning has to be preserved, not the epistemic meaning, as Carnap put it. The epistemic meaning of the second one, or the apparent epistemic meaning of it, involves a claim to know about the future. That's not being preserved by this translation, and that's the whole point. We don't want to preserve that because it's unacceptable. That's the whole point according to Goodman, not according to Carnap, but according to Goodman, that's the whole point, right? So, but it's going to turn out that we now know which things we say this weird thing about. They will always be found to bend when examined in the future. So we know the truth conditions for that statement. We know what makes it true or false. To say so-and-so will always bend in the future when examined under suitable pressure. And what makes it true is that the thing we're talking about is one of these, is the same kind as one of the things in this manifest predicate. Right? So when I see a scientist saying, all copper conducts electricity, I can, or actually, when I see a scientist saying this thing here will conduct electricity if examined in the future, and I want to check whether what they said was true or false, I could just translate that into this thing is either copper or, and then list all the things that conduct electricity. Basically metals, but also a few other things, I guess. Carbon nanotubes, whatever. All right. Semiconductors under certain conditions, etc. So, you probably should say conducts electricity under suitable voltage, right? Air conducts electricity if you build up the voltage enough. Well, sort of. Yeah, I don't know. Anyway, that's why there's lightning. But okay, never mind that. So, and you know, so in defense of Hume, uh, you know, Goodman says, and Hume gave an answer to what this auxiliary predicate is. The auxiliary predicate is, um, we're in the habit of thinking that this will conduct electricity. We associate the idea of this with the idea of conducting electricity. Not that Hume knew about conducting electricity, but um, um, if he could learn about it, that's what he would say. So Goodman says he had a perfectly good solution to the only real problem there. But it's not exactly the same as Goodman's solution, and he gives reasons why he thinks it needs work, right? So, but it's, but the type of solution that Goodman is going for, the solution is going to be, again, like, is of the same kind as one of these things in here. And yet, again, the solution is not going to work just stated that way because we don't know which are the projectable kinds. I was going to say something about Hume now. The way he discusses Hume is interesting. Um, um, Sorry, I'm just thinking about something else. All right, so I'm gonna something else I'm gonna have to talk to that I didn't realize before. I'll talk about later. But yeah, the way he talks about Hume is interesting. Um, the um, the story is something like this: that uh, you know, Hume, in a very common sense and reasonable way, gave a reasonable answer to the real question here. But then, since then, there's been a tradition of, there's been a smug tradition. Goodman uses the term smug here, of saying, hey, Hume, that's no good because you didn't say how to justify, you know. Um, and, and Goodman is coming back and saying, you know, you smug people who are asking for something else from Hume, you're the ones who are really confused and don't even understand what the real problem is. So, I mean, first of all, that's kind of a mean rhetorical move to talk about your people you disagree with that way. Um, and there's a certain meanness to Goodman and Quine, I think, which you don't really see in Carnap. Um, I mean, he does think that past metaphysicians were talking nonsense, but he doesn't rhetorically put it in terms that makes you feel like Carnap is the smart one. Carnap and we and Carnap are the smart ones, right? I mean, that's a typical move for a lot of kinds of philosophical author, where you say, like, um, you know, so and so made a stupid error, but we know better, right? Which, rhetorically speaking, means if you agree with me, you're going to be in the smart set, right? So anyway, so first of all, it is kind of a mean and perhaps also like tricky rhetorical move. But second of all, I feel like, but this again, with all these political remarks I'm making, I'm going out on a limb. But I know that Goodman and Quine in particular were much much farther right than Carnap. Carnap, as I said, was a socialist. Quine was quite right wing, actually. Apparently, he supported Nixon. I mean, I guess Nixon doesn't look that right wing by contemporary standards, but anyway, for the time. Um, so, and so, like, I feel like what you can hear here, and by the way, Hume was also fairly conservative, and more so as he got older. That was one reason he didn't get along with Rousseau when Rousseau turned up to stay with him in Scotland. So I feel like what's going on here is like we're seeing the beginnings of this weird dynamic where the people who see themselves, especially within academia, this is true, the people who see themselves as radicals or progressives, as we now say, right? Or at least as, yeah, maybe I should just stick with progressives, right? People who are on the side of the future, as Carnap puts it in the preface to the Aufbau, that the reaction to them from the right is that you guys are a smug establishment. And although we're conservative in the sense that, we like these old time people from way before you, in the present context, actually, you're the conservatives, right? Like you're the establishment and we're the rebels. And we're here to tell you that your smugness is unjustified. Okay, again, like, I don't know. I am going out on a limb by saying that that's involved here, but I mean, Goodman does make some explicit, just as Carnap does, later on make some explicit, at least metaphorical connections between what he's doing and, what we would normally call political or economic issues. Towards the very end of the reading, when he says something about entrenched capital and free enterprise. So I don't think it's a complete I don't think what I'm saying completely comes out of nowhere, but it is kind of conjectural. All right. Anyway, so because the problem has been put in this way, the problem is now, according to Goodman, not how can we predict the future based on the past, but what kinds of individual observations count as confirming general hypotheses. So I'm going to erase this picture. Well, I'm already starting to regret erasing it, but okay. I mean, this one of the confusing things, and it keeps confusing me every time I talk about this too, is like how we get from projecting predicates to projecting hypotheses. Because in most of chapter 3, he talks about projecting hypotheses. And there's even a footnote at one point where he says, like, what does it mean that a predicate is projectable? He says, what does it mean that a predicate Q is projectable? It means that some such hypothesis as this is projectable. So first of all, it's confusing because, before we were talking about projecting basically like the subject of, not the, I mean, it's still a predicate, P, right? But we were talking about like whether copper is a projectable type as opposed to copper or rubber, which is not a projectable type. Whereas now the connection between projectable predicates and projectable hypotheses is going to go through this. So, we might ask, is conducts electricity a projectable type? As opposed to like, is it a projectable predicate? As opposed to conducts electricity or is flexible, which is not a projectable predicate. It's confusing, but I don't think it's important. I think, either way, we're still talking about the same issue. We're talking about whether the predicates, all the predicates the hypothesis contain as a whole are, oops. Yeah, by the way, I should say, when I say it's a shift from chapter 2 to chapter 3, at the beginning of chapter 3, Goodman is still in the other mode, right? He's talking about the examples. The example he gives of a projectable hypothesis is all copper conducts electricity. And the example he gives of a non-projectable hypothesis is every man in this room is a third brother. It's likely not the case in 1960, what did I say this was? No, 1956, 53, or maybe it is the case that everyone in the room is a man. It could be. I mean, it's certainly, even in the 17th century, even in the 4th century, it wouldn't necessarily be the case that everyone in the audience of a philosophical lecture is a man. Well, anyway, sorry. So, but getting back to those, right? So those hypotheses, the problem is the difference between copper as a predicate and man in this room as a predicate. When you find that this piece of copper conducts electricity, you're building up evidence that all copper conducts electricity. When you find that this man in this room has 2 older brothers, you're not building up evidence that every man in this room has 2 older brothers. But as the chapter goes on, he switches to problems about this predicate. So as I said, it would be more like you were asking, why is the hypothesis all copper conducts electricity projectable, whereas the hypothesis all copper conducts electricity or is flexible is not projectable. Why do I say that's not projectable? So, like, suppose I have a piece of copper that's not under suitable pressure, and I connect it across this voltage gap, and it starts to conduct electricity. So this piece of copper either conducts electricity or bends. Right? I mean, this is not the way we use or, the real word or in real English, but this is the way the or operator works in sentential logic, if you remember from Phil 9. Right? So if either of the disjuncts is true, the disjunction is true. In English, it's not exactly false, but it would be wrong to say that. It would be weird. But anyway, in formal logic language, it's true that it either conducts electricity or bends under suitable pressure, I guess I could add. Right? Because it conducts electricity. So the fact that it's not under suitable pressure, and therefore doesn't bend under suitable pressure, is irrelevant. We already know when we check the first disjunct that it's true. So if the predicate either conducts electricity or bends under suitable pressure were projectable, then every time we took a piece of copper and found that it conducts electricity, we would be building up evidence not only for the hypothesis that all copper conducts electricity, but also for the hypothesis that all copper conducts electricity or bends under suitable pressure. But that's not right. It's irrelevant to whether it bends under suitable pressure, whether it conducts electricity when I conduct it up to this thing. So, so that predicate in this position also is no good. And that's the way he's going to go on to thinking about projectability. And, like I said, you can think of it, I mean, basically, you can think of this as part of the thing about is examined, right? So the predicate you're trying to project is conducts electricity, and the condition is examined when copper, or something like that. Is copper examined? Is found to be copper? And you're trying to predict whether the things that are found to be copper in the future will also conduct electricity. Again, if you found that more confusing than helpful, I guess you can ignore it. But if you go back and start getting confused how the predicates are related to the hypotheses, you might want to think about what I said or rewatch it. You have that option. Someone told me that they rewatched parts of my lecture over and over, and I was like, wow, I hope I was really careful about what I said in that part that he watched over and over. But anyway, right, so what's the problem with this? Well, I mean, so first of all, there are a lot of problems with this. A lot of problems were developed about this by Hempel and Ernst Nagel, not Thomas Nagel. I don't know if they're even related. I never determined that. But anyway, by, various people developed problems about, again, the issue being when does observation sentence, he calls them S1 and S2, but let me call it something like O and U, right? When does an individual observation sentence count as confirming its universal generalization or a universal generalization? And so there's all kinds of like false starts or paradoxes you can get if you try to solve this problem in too simple a way. The most interesting one he discusses is the Raven paradox, where, the statement, all ravens are black, right? For all x, if x is a raven, then x is black. So we understand why, like, A is a raven, or like we want it to come out that A is a raven and A is black, confirms this general law. But it turns out that this general law is equivalent to this other general law. Let me use the same symbol this time. Right? For all x, if it's not black, it's not a raven. These two are equivalent. Right? It's true that all ravens are black, if and only if it's true that everything that's not black is not a raven. Do people understand why those are equivalent? If we found something that was not black but was a raven, then it wouldn't be true that all ravens are black. And on the other hand, if we found a raven that wasn't black, it wouldn't be true that all things that are not black are not ravens. So they're equivalent. But that, if we apply this same procedure, is that still visible? Yeah. If we find something that's not black and not a raven, that should serve to confirm this, just as this serves to confirm that. But since these are equivalent, when you find something that's not black and not a raven, you're confirming this, because you're confirming this and it's equivalent to this. So, if here's this thing here is not black and it's not a raven. Here's a piece of evidence that all ravens are black. That's the paradox. So he says that paradox has already been solved. I'm not worried about that. And there's other technical difficulties like that, but they're all promised to be solvable by technical means. By fixing up what the rule is here a little bit, or something like that. To show why you can do this but not this. Or to show why, given the assumptions you're implicitly making about the situation, this would serve to confirm that. Those are the two kinds of fixes. I guess it's more of that one in this case that he's looking at, but let's forget about that because he says that's not a big problem. But he says there is a big problem, and that problem is what he calls the new riddle of induction. And to get the big problem, he introduces this new predicate, which he calls gru. Right? This is famous. Gru, like philosophers now talk about gru left and right when certain issues come up. He was the one who invented it. And gru is defined as green and first examined before T, or blue and not examined before T. Oops. So, suppose it's now before T, whatever T happens to be. Suppose we're now before T, and we've examined a lot of emeralds and found that they were all green. So all the emeralds we examined were green, and all the emeralds we examined were first examined before T, because again, it's before T and we've already examined them. So therefore, all the emeralds that we've examined were GRU, according to this definition. And I think it's important to realize that I think it's important, even though actually in his foreword, Hilary Putnam says this isn't important and gives a different definition, which this is not true of. But I don't think he's right. I think for Goodman, it's really important to notice the following things. You can be sure when you examine a green emerald before T, you can be sure it's GRU. You don't have to wait to see what happens at time T. Right? Because you already know that it's green, and you already know that it was first examined before T. So it's definitely GRU. And similarly, anything you examine after T, if it's blue, I mean, anything you first examine after T, right? There's a relativity to who's doing the examining here. Like, examined by whom, but that's probably right. We want the validity of an inductive inference to depend on who is making it, right? Like people who are not part of the community that's done the examining don't have a basis for making the inductive inference. So anyway, right, so if I know that we haven't examined it before T, whoever we are, and I pick it up and I see that it's, so I'm examining it for the first time and it's blue, then again, I know it's GRU for sure. I don't have to know anything about what happened before time T, because I know it was first examined after time T, and therefore it was not first examined before time T, or was not examined at all before time T, right? Is what I know it was first examined after time T, therefore it was not examined before time T, and it's blue, so by this definition, it's GRU. And so, like, nothing happens at time T. Nothing changes from one color to another. Nothing changes from green to blue, and nothing changes from GRU to bleen, which I don't want to take the time to write it up here, but bleen is just GRU with the definition reversed, right? So bleen means that it's blue and first examined before time T, or green and not examined before time T. So like whether you use the colors green and blue or the colors GRU and bleen, you still will say that everything stayed the same color. I mean, well, I guess some things change color, but everything we normally would say stays the same color at time T. Like emeralds, right? Emeralds lying in the ground, let's say. I don't really know. I don't think it's true that all emeralds are green, by the way. I think they come in different colors. But let's say, as far as I know, emeralds lying in the ground don't suddenly change from green to blue. And similarly, they don't suddenly change from bleen to GRU or GRU to bleen. Okay, so do people understand what GRU is? Is there a question? What it means for something to be GRU? Notice that if we assume that green and blue are manifest predicates, then bleen and GRU are also manifest predicates. For the reason I just said, right? That is, when I pick something up before time T and I see that it's actually green, I mean, so No, okay, let me not get into that. So I see that it's actually green. I know it's GRU. I don't have to know anything about how it would behave under other circumstances, how it will behave in the future. I know that right now it's GRU. It could change and not be GRU later, let's say. Um, uh, but, well, actually, could it? Uh, yeah, right. It could change and not be GRU later. How could it change and not be GRU later? Suppose later it becomes blue. Right? If you're confused about what GRU means, you might think that that means it's GRU because it was green before time t and now it's blue after time t. But actually, if it changes from green, um, whether before time t or after time t, it won't be GRU anymore. Why? Because what won't happen at time t, it won't change from first examined before time t to not examined before time t. Once I've examined it, it's always going to be something that was first examined before time t. So it's always going to be on this horn of the definition. And so the only way for it to be GRU is always, the only way for it to always be GRU will be to always stay green. If it ever changes and isn't green in the future, it won't be GRU. Okay, so so therefore, again, GRU is a manifest predicate. I can determine whether something is actually GRU right now just by examining it now. Okay, so the question is, I mean, I hope it's not a big surprise what the question we're heading up for here is. So, okay, so we've examined all these emeralds before time t, and we found they were green, and that seems like it's good evidence for the universal law, all emeralds are green. At least it seems to Goodman that it is, and Carnap. So whether it really is, I don't know. I don't want to get into. But it certainly it seems to them like we're building up evidence for this universal law. All emeralds are green. But look, all those emeralds we examined before time t. Well, sorry, all those emeralds we've examined so far, and again, we're assuming that now is before time t. All those emeralds we've examined so far, not only were they green, they were also all GRU. So why haven't we built up evidence instead for the hypothesis all emeralds are GRU? But those hypotheses contradict each other, right? They're different hypotheses because they make different predictions about what we'll observe after time t. Again, not about the emeralds we already have, right? The emeralds we've already examined, when we predict that they're going to be GRU in the future, we're just predicting they're going to stay green. But the new emeralds we haven't examined yet, we're predicting will be blue. Now, I mean, of course, sometimes the same observation can support two conflicting hypotheses, right? It's consistent with both of them, but not with other hypotheses that it rules out. So it provides support for both of them, but it doesn't decide which one is true and which isn't, right? And then, as Goodman says at one point, so we need a crucial experiment, right? That's Bacon's term, I believe. Crucial experiment, right? Like a crucial meaning like a crossroads, right? It's an experiment where like that will tell the difference between the two, that only confirms one and not the other. But if you look at what happens here, Goodman says, well, And obviously, just by fixing this definition in certain ways, you can make the same observation confirm anything. Right? You can make it predict that all emeralds you examine in the future will be blue, will be red, will be flexible, will conduct electricity. And not only that, you can make it predict that all roses in the future will be blue, because you just have to define a predicate emerose in the same way we've defined GRU here. And you can say that so far we've found that all emeroses are green, and that will well, no, it's not. That's not quite it. But anyway, using that predicate emerose, you work out the details. You can collect evidence. I guess no. Here's the so. Just focusing on the single statement, this emerald is green, that can count as evidence that all roses are blue, because it can count as evidence that all emeroses are, I guess it should, no, it can count as evidence that all roses are green, because it can count as evidence that all emeroses are green, where emerose means something that is first examined before T and is an emerald, or is not examined before T and is a rose. Right, so any observation can be made to count as confirmation for anything by choosing the right hypothesis. If we use a solution to that general problem of induction that can't distinguish between projectable and non-projectable hypotheses, or that is, can't distinguish between projectable and non-projectable predicates. So can't distinguish between green and blue, which are projectable, and GRU and bleen, which are not, or between emerald and rose, which are projectable, and emerose and rosamolds or whatever, which are not. And this is a devastating problem for Carnap. Why? Because, look, you can see that GRU was introduced by a definition using green and blue. Right? This is actually an explicit definition. It's not a reduction sentence or anything like that. This counts in the sense of the Aufbau as a construction of the concept GRU. So if green and blue are legitimate concepts, GRU should also be a legitimate concept. And yet, although green and blue, I guess, well, I put it this way, even on the assumption that green and blue are legitimate concepts, which I think that Goodman and Carnap agree that they are, GRU definitely is not. In what sense? Well, remember, for Carnap, legitimate concept was supposed to mean that we can collect empirical evidence for and against the statements that include that word, or the word that stands for that concept, or the word that is that concept, according to Carnap, or the word whose extension is that concept. Right, so, and yet, although we can collect evidence for and against all emeralds are green, we can't collect any evidence for or against all emeralds are GRU. Right? Every time you pick up something and you see it's green, and again we're assuming that it's before time t, everything you pick up something and you see it's green, it's also GRU, but the fact that it's GRU gives you no reason to expect that anything else will be GRU. or, well, it gives you no reason to expect that everything else will be GRU. In particular, it gives you no reason to expect that anything not examined before time t will be found to be GRU when it is examined. So it's an illegitimate, it's an empirically illegitimate concept, and yet it's syntactically dependent in the right way on these legitimate empirical concepts. And that means that Carnap's project of providing a syntactic distinction between legitimate and illegitimate concepts has failed, unless we can find a solution to this somehow. Right, there's 10 minutes left. I mean, I was going to say something about how Carnap actually reacted to this, but maybe I shouldn't. There's a footnote in Goodman where he refers to he actually had an exchange with Carnap about this. If you follow that up, you can see that Carnap in the end was not happy with his solution, but it was the best he could come up with. But anyway, so I'm not going to get into that. I'm going to say, like, okay, just going to say briefly what is a solution that won't work. So, or at least it won't work understood a certain way. So the solution we want is to say, look, GRU is not a good predicate because its definition refers to a specific time. And predicates like that refer to specific times or locations in space are not projectable. So we would also say that about the thing about, all men in this room have 2 older brothers. That predicate is not projectable. And similarly to the example I mentioned before that Goodman also mentions here, like from finding that this piece of copper on my desk conducts electricity to build up evidence that every object on my desk conducts electricity. Right? All those things, those concepts that are like at this time, in this place, are not projectable. So if that's supposed to mean that, I examine the hypothesis to see that it explicitly refers to a certain time or place, and if it's not, I say we can't collect evidence for that hypothesis, it's not projectable, then the example of GRU already shows that that won't work, right? Because GRU, once you do this definition, you can make sentences with GRU that don't refer to any particular time or place. So you say, well, no, hold on a second. That's, of course, that's a trick. GRU was defined in a way, its definition involved a time or place. So it didn't end up in the final hypothesis, but it's still there by way of the definition. But the problem is that, as Goodman points out, you can also define green as GRU and first examined before T, or Boolean and not examined before T. Right? Because if it was examined, if something was examined before T and it's green, then again, it's definitely GRU. And if something wasn't examined before T and it's green, then again, the definition of Boolean just has blue and green reversed here. Right? So in particular, this part of the definition of Boolean says green and not examined before T. So if something is Boolean and not examined before T, it's green. Right? And vice versa. So this is a perfectly good definition of green. If we don't know in advance whether green and blue are the good predicates or blue and green are the good predicate, sorry, did I say blue and green twice? If we don't know in advance whether it's green and blue or GRU and Boolean, we can't tell by looking at these definitions which one is good because they look exactly the same. So what is Goodman's solution? the solution is in chapter 4. I mean, it has a bunch of complications in later parts of the chapter that I didn't ask you to read. But the basic solution is this, that he says, look, let this be the universe of all hypotheses. So, here are the ones that, the hypotheses that, he doesn't give a really clear explanation of what this circle is, but I'm saying here's the circle, the hypotheses that have actually come up for consideration, right? And within that circle, we can draw a line between the ones that were projected and the ones that were not projected, right? So in other words, these are hypotheses that someone actually made, and there was something that could be counted as evidence to confirm them, but we didn't count it as evidence to confirm them. And here are the hypotheses that were actually made, and there was something that looked like evidence to confirm them, and we counted it as evidence to confirm them, so they actually were projected. So Goodman says, look, all we have to do is project this one predicate, actually projected, out into the universe of hypotheses that haven't been come up for consideration yet. And then we'll have the predicate projectable. And how do we do that? Well, we look for an auxiliary predicate that applies to all of these, an auxiliary manifest predicate that applies to all of these, but also applies to other hypotheses that, I mean, look, you could just say hypotheses that haven't been examined yet, right? That haven't come up for consideration yet as inductive hypotheses. Find something like that. And then we can translate the statement, this hypothesis is projectable, into a statement that just talks about the actual properties of actual hypotheses and doesn't talk about the future or the possible. And how are we going to do that? Well, his answer is, so again, it has to be something that we can know now that these hypotheses we haven't even thought about whether they have it or not. And what it is, which predicates they contain. Right? So, like, we want it to come out that, again, you could just imagine a list of all the predicates of all the hypotheses in here. Green, blue, copper, rose, etc., etc. So the auxiliary property A is going to be, contains only predicates from this list, green, blue, copper, rose, emerald, blah, 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 blah. And now we know, it will turn out by definition, that all and only the hypotheses that have those predicates in them are projectable. Boy, there's 1 minute left. I cannot possibly do justice to this solution in 1 minute. I'm afraid, even though I have to talk about Quine next week, that I have to spend a little bit of time on the beginning of the class on Tuesday on this. But I'll just say that as a preview, the question is now, but wait, this is just the same problem back again, right? We don't know in general how to find a predicate, auxiliary predicate A like that. So Goodman says, well, yeah, we don't know how to find one in general, but remember I said it would be okay to find one just for a particular case. If we're willing to accept the translation and say that it has the same extension, then even though we don't know the general rule, we've managed to get rid of that one dispositional predicate. And in this case, the one dispositional predicate is projectable. And if we can get rid of that, we can get rid of all the others. And the proposal is, what is this auxiliary predicate? And the auxiliary predicate is basically that hypotheses using this predicate have been projected lots of times and not violated. So it's that we're used to projecting using this predicate, basically. We're in the habit of doing it. As he says that's loose, but he says in Humean terms we could say it's the predicates we're in the habit of projecting. So the translation of this hypothesis is projectable is this hypothesis contains predicates that we're in the habit of projecting. And so again, I want to say what I also said at the very end last time. I didn't have time to get into. This is inherently conservative. That's why Carnap won't like it, basically. This says, what are the good predicates? By and large, all other things being equal, the ones we're already using are the good ones. Okay, I'm sorry I'm 1 minute over time, so I will see you all next week. Bye.